think we're good to go, John.
All right, everyone. Welcome to the first Systems Facing Track call of 2022. I hope you all had a great holiday season. To start off, though, we did add a new member to our steering committee. And so if you all would please welcome Matthew Smith. He's a manager of research systems at the Advanced Research Computing Center at the University of British Columbia. So everyone give him a warm virtual welcome.
Hi, everyone. Thanks for having me and looking forward to helping out.
Thanks for participating with us, Matthew. So to kick off this new year, we'll start off with a talk from Adam Michel, who is a principal systems administrator at the University of Arizona. And he will be giving us a summary of their experience standing up and living with an all-Broadcom RoCE fabric in support of their most recent cluster acquisition, Puma, at the University of Arizona. Adam, take it away.
Hi, that's me. I'm Adam. Let me make some slides appear here. Maybe. Of course not. There we go. Good grief. Haven't done a slide share since I set up a new computer. Give me 1 second. There we go. Hopefully. Slides?
Looks good.
Wonderful. So real world RoCE. We actually did it. You may have read about it. We have taken it on. First off, who am I? I don't think I know really anybody here except the people that work with me. So as John said, I'm a principal systems administrator at the University of Arizona. I used to work for the enterprise team on as a systems programmer long ago when that was still a title. I was a solutions architect for about 15 minutes. And you guys know how it goes at universities, other duties as assigned, they come along. But as a person, I like hardware a lot, and I like making interesting infrastructure things happen, and I like working in my own data center. And I also sort of like working on networking. And so that's how this happened to us and to me. Where are we? University of Arizona. If you're not familiar, we are not the one in Tempe. We're the one in Tucson. Arizona's first university, required by law to put that in there. Some of you may be wondering why I hate InfiniBand. I have several answers to that question. Hate's a strong word, you know, but have you ever used it? It's not the best. It's not the worst. If you need it, it's worth doing. Generally speaking, it's, you know, not cheap, assuming this is going to build for me. So unless your money printer is pouring money directly into NVIDIA's headquarters, sometimes there are things to think about there. Generally, sometimes you just want to try something new and see how it goes. And we did that. Why do I love Ethernet is maybe a better question. I don't have a great answer for that. Ethernet has wronged me also, but I've used it for a lot of things and I'm pretty good at it. So got that going for me. But this is the true violence of InfiniBand. Single, double, quad, these things make sense. Full, enhanced, high, next. We should all be revolting. But we don't hate InfiniBand at the University of Arizona. Here is a brief history of our clusters and interconnects. We have used many, many things. XIO from the origin days. We've had MiraNet, represent MiraNet. We had an alpha with Quadrix ELAN. We've had several flavors of InfiniBand you can see on the sheet there. Numalink, all the things, right? Solve problems with the right thing. Don't necessarily just buy the thing because it's the thing. RoCE, RDMA over Converged Ethernet is what that stands for. Because this is a networking topic, we are going to have some TLAs. Despite Cisco not being involved, it's a requirement anytime you talk about networking. So I apologize for the density of the slide, but the other slides would have been so long you couldn't read them if I didn't put some definitions up front. So here we go. Converged Ethernet / data center bridging. This is an extension to Ethernet that makes it selectively lossless. This was really driven by fiber channel over Ethernet. The idea was to converge those two fabrics into a single fabric because you had a lot of bandwidth for Ethernet that you weren't always using. Could you run other things over it? Could you run Fiber Channel over it? We used Fiber Channel over Ethernet extensively here at UofA for our core systems. I mean, registration, paychecks, et cetera. We ran a system like that on Cisco Converged Ethernet using Fiber Channel over Ethernet on Nexus switching. We were one of the first, I believe. I mean, we had the first generation QLogic CNAs, converged network adapters, that had literally an HBA and a NIC right on the card, 2 different chips. You could just see them with your eyes. Priority-based flow control is the thing Cisco brought to Ethernet to make Ethernet look lossless. Fiber Channel couldn't tolerate loss. That's not designed to tolerate loss. Fiber Channel fabrics have a credit mechanism that guarantees things don't get sent unless they can be received. This is Cisco's attempt to make Ethernet lossless, and it works. I mean, you have to configure it properly, and it's a little bit tricky, but that's what PFC is. You'll see it come up later. Class of service, this is if you've done any layer 2 networking where you needed to QoS traffic. Class of service is the thing you use for that. It's a value in the header that just tells you, well, you tell the switch which values are more important than others. DSCP, the dreaded 4-letter acronym, is like class of service, but for layer 3. So when things exit the layer 2 subnet, go out across a layer 3 link, this is a way to continue indicating their priority to that entire fabric. So that will pass through routed hops. Explicit congestion notification. This is a protocol essentially wherein the sender, the fabric itself, and the receiver all passively monitor for congestion. So when the sender sends a packet, tags the packet to say, I would like to know if there's congestion along this route. If any switch participating in ECN sees congestion for that packet along the route, it flips a bit in the packet that says, yes, there was congestion. No other information. Very simple protocol. When it gets to the destination, if the destination sees that bit is set, it sends out a congestion notification packet. That goes all the way back to the sender and tells them there was congestion on your route. And the sender reacts to that in whatever way the protocol decides, typically just slowing down the send rate to hopefully avoid the congestion. And you just essentially have a feedback loop there of if you continue getting CNPs, you continue reducing your sending rate until they stop appearing. So those will all come up. What is RDMA over converged Ethernet? What does it actually look like on the wire? Actually, very simple. FCOE was exactly this simple also. Take a frame of the thing that you want to send over Ethernet, put an Ethernet header on it. In this case, give it a QoS value, a COS value to tell the network that it's high priority. Send it over Ethernet like any other packet. Destination unwraps that Ethernet frame, and there's an InfiniBand frame in there. Bingo, bango, very easy. Layer 2 only. RDMA over converged Ethernet version 2. In this case, we're trying to send this over a layer 3 link. So we want to extend beyond a simple layer 2 subnet out into a larger layer 3 subnet. The way you do that is to do essentially the same thing, but we add UDP IP on top of the Ethernet frame. So that allows us to wrap that up and send it over a layer 3 hop. Otherwise, very similar to the previous thing. You send it across the thing. It does all the prioritization tracking across the thing, including ECN. On the other end, unwrap, unwrap, unwrap. There's an InfiniBand frame in there. And, again, that extra step of sending that congestion notification if you have seen it along the route. Come on, Google. Oh, there we go. Resilient RoCE. You'll see this word when you start Googling for RoCE. I don't have a good definition for this. I'm not going to try to define it for you because as far as I can tell, it is not exactly a specification. It's kind of a specification, but fundamentally, as far as I understand it, it takes RoCE v2 and adds essentially a retransmit mechanism built into the protocol. So you do not need to have strict losslessness along your path. The idea was to be able to extend this over longer layer 3 links so you could ostensibly transmit RDMA cross country. Why would you be doing that? I don't have a great answer, but that is ostensibly the idea. I see this mostly associated with Mellanox. I don't know that that means that it's theirs, but they're the ones I see talking about it. So it's out there. And if you see it, you'll have to ask whoever told you to look at it, what it means exactly. What about iWARP? iWARP's been around for a long time. core difference, and this is not getting into the deep specifics. If there are any Chelsea diehards in the audience, I'm sorry, I'm not going to do this the justice that you may wish I could do it. It's basically like RoCE v2, except it uses TCP IP, and it depends upon TCP IP's retransmitting mechanisms to make sure all the data gets where it goes. So you get some of the reliability out of the network just sort of implicitly, the same thing you would have for any TCP conversation. So that's the core value of it. That's the typical pitch you will see. iWARP depends on proven technologies like TCP. The downside is it depends on proven technologies like TCP, which are well known to not be particularly good on the modern internet with high-speed links. There's tons of research if you start poking around about trying to sort of combat the downsides of TCP on like the modern internet. And in particular, things like Google's Quick protocol, or what is now, I believe, called HTTP3, which is essentially trying to run TCP over UDP to some degree or another, re-implement some of the stuff there. So anyway, that's the iWARP story. It's out there and it still works. And fundamentally, there are still vendors like Chelsea, I believe, Intel, that are iWARP only. Little bit of a, I guess, holy war situation there, as tends to happen. How to get yourself a RoCE. Decide you want one. You can tell from the rest of the presentation, I don't think you should let somebody sell you this. I think you should want to get it. This is not trivial drop-in right now. Our integrator didn't really have any experience with it when we decided we wanted it. So you just should be prepared to take it on and all the things that are going to come with it. Maybe there's somebody out there who would be happy to stand up, in your RFP process and say, I definitely know how that works and I will definitely make it work for you. That's not what happened to us, but we didn't expect it. We expected to have to do this ourselves. And so things that we considered beforehand to kind of decide that was the case, we looked at interface statistics on our existing cluster, which had InfiniBand. Was it burning up the bandwidth? Did we have a ton of jobs, job accounting history relevant here, that were spanning enough nodes to really care about the latency values of InfiniBand or the bandwidth values of InfiniBand? Did we have any users that could show us a code? This absolutely requires InfiniBand. There are no ways to use this without real live actual InfiniBand. We had some users that tried to demonstrate that to us, and I thank them for their service. Honestly, it was great to see somebody engage. We didn't have anything that showed up that was like, no, it's clearly using all the bandwidth of an FDR InfiniBand port. It's clearly depending upon the 50% lower latency of that FDR InfiniBand port. And the last one was really just the confidence that we would be able to personally ourselves get in there with our hands and make it work. Because again, we weren't highly confident that we were going to have a ton of support. It's still relatively new. Story is better now, a year later, but at that time, we were asking for something a little bit odd. Step 2 is to ask for it. We're into the RFP process. This is what we did. Some of our vendors did not like it. We've done this twice in a row now, but we split our RFP up into separate sections. When they bid compute, storage, and fabric separately. And we tell them that if you bid on our RFP, we will buy whichever one of those 3 things from you. We feel like maybe all 3 of them from you, but you can't bid one giant system all as one thing. You have to bid these 3 sections individually. Some of them are not fans of that. Some of them submit a bid with all of them in them anyway. And then at the end you say, but I just want your storage. And they're like, but you can't just have my storage. Like, well, bad news. Your bid is no longer good. And the other one that I'm going to say confounds them, we just had some difficulties explaining what we meant. We weren't trying to maximize total system LNPAC. We weren't looking to land on the top 500 list here with a full system run. For our users, that's just not particularly a relevant metric. And so a lot of the things they do to like optimize amongst a whole system, we kind of take away from them. So anyway, what was in our Ethernet fabric section? This is what we asked for at the highest level. Since we weren't tying it to the compute section, we had to give them something to bid. So what we asked them for were 300 and 600 client configurations with the clients at 25 gigs, 800 gig connections to a storage system. We didn't know which storage system at the time either, but we knew it was going to be Ethernet. We were requiring NFS Ethernet for our storage for this particular bid. And 4x40 for campus uplink was just sort of a that'll be enough, to get us to the rest of the campus. If storage is plugged directly into the fabric, we weren't too worried about it. What we ended up doing was putting storage outside the fabric and just putting it on a bunch of 100 gig links also. That was a post decision, but this was basically the straw man that we had them stand up. And for the switching, we weren't requiring specific vendors or specific ASICs or anything. Just you have to have these sort of basic things. We have to be able to log into with SSH. We're not looking for an SDN fabric that you program with a cloud controlled Kubernetes something. It had to have all the features we needed to do RoCE, which are the things like priority flow control and traffic prioritization, ECN, etc. Internally non-blocking on the switch. That's pretty table stakes these days, but good to write it down. And for the total fabric, no more than 3-to-1 blocking ratio for node on switch A to node on switch B. So that's just kind of an uplink to downlink kind of thing. And that's stuff that we have sort of sussed out from previous things in terms of what our bandwidth utilization is. 3-to-1 is a pretty good mix for us. Step 3, buy it, which brings us to, we bought a RoCE, the University of Arizona story, coming soon to Lifetime. What did we buy? We bought from Penguin Computing, who was our compute vendor, it turned out, so they won too, good for them. We bought their Penguin Arctica 3200C. That is a Celestica C-Stone painted bright yellow. It has a Broadcom Tomahawk in it. It's very similar to every other Broadcom Tomahawk switch you've ever seen. In fact, 75% of the Broadcom Tomahawk switches you've ever seen are all Celestica C-Stones. It's crazy. You just look at the front and you're like, oh, those are all exactly the same. For the nodes, we also got Broadcom NICs. They're all based on the cleverly named BCM 957414 25 gig chipset, but we ended up with 2 different form factors for supply chain reasons. The M225P, which is an OCP module, and the P225P, which is a PCIe module. They are functionally identical. They use the same firmware. They, in fact, act exactly the same. They just are in a different form factor. Software-wise, on our switching, Penguin at that time was still able to sell us Cumulus Linux, which is the best. I've never been so mad at NVIDIA in my life for buying Cumulus and ruining it. But it is great, and we had good luck with it. Just a note, if you're buying Broadcom switching now, you can't get Cumulus anymore. It is no longer available. If you want Cumulus Linux, which I will be talking about later as some config things, you have to buy Mellanox switching now. That's it. They're just turning off the Broadcom support. Hooray for all of us. And for our nodes, we're still running CentOS 7. We're working on a small new cluster with CentOS 8. Nothing to report there yet. It seems to work essentially the same. So this is what the fabric ended up actually looking like. We did a spine leaf fabric, 4 spines, 2 leaves per rack. What we ended up doing was a dual port NIC, 10 or 25 gig for storage on port 1, MPI on port 2, very simple config. For each leaf, so this is where it gets a little bit network wonky. We did a full layer 3 fabric here, and we do not have any overlays. So it would be very, I'm going to say fashionable these days to throw VXLAN or some sort of layer 2 virtualization on top of a spine leaf fabric like this to avoid having to deal with routing. I was looking to do the opposite, which is avoid having to deal with VXLAN. So we did a lot of routing. We just assigned a /26 to every leaf and used route distribution to distribute them. Because we're doing RoCE v2, which survives routed links, that really wasn't a concern for us. We didn't need the overlay to make this work. It wasn't even particularly clear to me, just as a point of order, that the overlay would solve the problems you need to solve with PFC, because it's still transiting those things over layer 3 links. They're just encapsulated. So that would be a problem for you to investigate on your own if you decide you don't want to deal with the routing. But what we ended up with was a very simple OSPF fabric on the inside. If you've done routing before, OSPF is one of the very simplest, I suppose, I guess I would say, dynamic routing protocols. Because we're using Cumulus, we found that config to be comically easy. They have support for, and you'll see these things in other vendors also, but support for what they call unnumbered variants of these routing protocols, which means you don't have to assign a whole bunch of IP addresses to all these switches to make them speak to each other. You just tell the thing which ports the upstream switches are on, and they just set up with auto-negotiated IPv6 addresses. All of their route transiting is like with magic. I'm just like waving my hands. So the whole config for the entire spine leaf fabric in terms of the OSPF, it's like 6 lines. I mean, it's just comically trivial. So very nice. Again, Cumulus Linux, my heart, it hurts daily. Upstream, we have a BGP core. So on that edge switch that you can see at the top of the diagram, OSPF on the inside, that's how all of those things sort of find each other. They advertise to that edge, which then re-advertises those OSPF routes out to the core of our room, to our room edge, we would call it, with BGP. Config highlights specifically in Cumulus, what you need to do to make all of this quality of service, guaranteed losslessness work is tell the ASIC what's important. And in Cumulus, that means using this specific config file to, it basically reads this config as it's doing the ASIC initialization. So when it's bringing up the Broadcom Tomahawk, programs in all of these values. Oh, I should have mentioned upfront, I provided, and I think there's a link in the document, a tarball with a bunch of config files that you can look at, some scripts and things that we set up that you'll see come up later. One of those things is a copy of the traffic.conf from one of our leaves that shows you kind of all the things we set up, how we identified all these things, but you need to tell the switch, tell the ASIC which classes of service are the important ones, which DSCP IDs are the important ones, which ports it should be applying those policies to. A fun note, the format for the list of ports in this config file is different from every other list of ports on Cumulus. So we set this up once and thought everything was fine, and then realized none of the QoS was working, and it was all because we used the wrong formatting for the port list. So just a fun fact for you. The nodes, many things on the nodes. NIC firmware turned out to be very important. When we were on factory firmware, there were settings that would look like they applied that absolutely did not apply. Some of the things that even documentation said would happen, wouldn't happen. Very odd. We just upgraded them to whatever was current at the time. We've settled on a version now, which I don't have listed here, but fundamentally we took it all the way to the newest that was available, and that's how we got everything kind of doing what we wanted. Once you have that firmware programmed onto the NIC, which you can do from within the OS, blessedly, is to set firmware settings on the NIC. So obviously there's a full, as is the case with every card you put in a computer now, there's a whole operating system in that NIC also, right? Which is super fun. And inside this NIC in particular, there is an LLDP responder. There are things that will do the marking for you for RoCE. Some of these things I think would be convenient if I understood how to make them work, but it wasn't clear how to make the onboard things do anything we wanted them to do. So we needed to be able to turn them all off. We also need to do things like set up the number of exposed interrupt queues and things like that. That's all done with the same tool that does the firmware upgrades. Once you set them, they stick. So that's nice, but you do have to set them, and there are several to set. It's provided in the tarball. And sometimes you hit next slide and nothing happens. Oh, there we go. So you got the firmware. That's nice. Did I do these in the wrong? I skipped one. There it is. Now you need to solve drivers. There are 2 drivers because, of course, there are 2 drivers. It's the same on Mellanox, so this isn't really Broadcom's fault, but BNXT-EN, BNXT-RE. Even CentOS 7 had built-in drivers for these things. The devices came up. They don't work right. Ethernet works fine, to be fair, but RoCE does not work, even if the device, even if the RDMA device appears, it's not doing what you want it to do. So never trust them. Of course, they don't work. That's the, truth of putting a card in a computer. You need the upstream drivers. Broadcom does provide packaged drivers, which seems very convenient until you realize that they have pinned them to explicit kernel revisions. So when you yum update to address the most recent whatever nightmare security issue and your kernel revision goes up in some bizarre way, those drivers don't work anymore. It's a thing you learn accidentally after 2 maintenance windows when none of the RoCE works after you turn the system back on. Always a fun time. So what do you actually do? Well, you compile it like a champion. Obviously, like you just resign yourself to that early. We are basically just installing it In some cases, we started there. We started trying to package it, and I mostly have that working. They do provide spec files that'll generate RPMs. As if anybody here has used RPM build before, you know that's never fun. It's always a experience. So maybe that's the way you want to go. Maybe it isn't. DKMS, I'm trying to make work now on that new cluster. Comically, this driver is very easy to install as kernel drivers go. I've built things that are much worse than this and made them work in DKMS, but this one's very easy to do with your hands and very hard to do in DKMS. It's very bizarre. So anyway, whatever suits you, that's how you're going to have to get the drivers in there. And every time you update the kernel, you're going to have to do your thing again. So there's that. So you got drivers and you got firmware. Great news. You can finally start setting settings. There are several things that need to be set, and rather than implementing them as module options like sane vendors everywhere have done for all time, they implemented it as a config fs. I think that's the right word, implementation, which means there's a pseudo file system as is Linux's case. There's a pseudo file system where you have to echo some things into files that don't really exist that set settings for the driver. They have to be set every time the node boots. So you have to figure out a way to have all of those things get set after the node boots up. So what we ended up doing was writing our own script to do that at start time and making a system D unit that runs it. It has very basic dependencies. So once network stack is alive and LLDP is up, it starts doing some stuff. It sets a few things that we want with LLDP. So if you've used LLDP before, you want things like admin status or admin name. I'm getting some of those words wrong, but basically I like it when it tells the switch upstream what its name is, because it makes working on the switch and debugging ports much easier. So we set those first, and then we call into a Broadcom provided script, which is bnxt setup CC being congestion control in this instance. This script was very difficult to find. I ended up digging it out of the driver source file. It's buried in the rocky parts of the driver source for reasons. It's essentially in their documentation required to make this work, but it doesn't come in any of their packaging. So that's a fun thing. It's a little more complicated than I want. So we cooked parts of it down and kind of simplified it. So in the tarball, also I provided the local version of this where we pulled out some of the stuff they use for setting up, I'll call it highly available. If you have LACP, they can sort of set up an RDMA device on top of the LACP device. So you get some fault tolerance there. Just made things more complicated. It was hard to kind of follow. They also have a tool for using their own QoS tool instead of LLDP to set some of the QoS parameters that go out to the fabric, I should say. I didn't want that. I didn't want to use it. I didn't want to wonder if the script was using it. So anyway, those are some of the things we cleaned up there, but it set several things. So you got all those things working. How good for you. Now you also need to trick lib IB verbs into speaking RoCE. They provide a library for this, libbnxtre. It's a packaged thing again, and it installs fine, but it is an overwrite install. It's the classic worst case packaging situation. So if you update libIB verbs, it overwrites all the changes and you need to reinstall libbnxtre. We've just taken to every time we do updates of any kind, rather than did the thing get updated, we just reinstall every time just to make sure it has put itself back where it belongs. Otherwise, nothing works. So that's fun. And finally, all of those things are together. Now your MPI libraries need to, do the thing that they're supposed to do. This is a selection of things we had to set explicitly. We set them with environment variables. There's an example there from Slurm to have SBatch pick those things up from the environment. I've included the file we use to set these also in the tarball, but you need to set all of these things so when you load up OpenMPI and it tries to do things, it does things the way you want them to. So that was a lot of how to make it work. Does it actually work? Yes, it absolutely works almost all of the time. It's not a full 100% drop in, but for most things that you're going to try, it's actually going to work just fine. You aren't really going to notice. Once you have done all of those other things to convince your system that it is a real thing that does real work, that can really send RDMA, most of it is just going to work. we have these particular ongoing issues with these specific codes. We have a user using this weather code, and when he scales above 5 nodes, his performance gets bizarre. Just strangely erratic. Below 5, fine. Above 5, not fine. Hard to explain. Really, lots of debugging. Athena is an astrodynamics code. It has some issues with IB retries, which feel very much like it's trying to talk to something on the wrong interface, but it's difficult to figure out what it's trying to do. IBAMR mathematics, this one just throws errors at startup, and we can't really figure out why exactly, because nothing, I mean, it just won't initialize sending. Very bizarre. Anyway, those are just some examples. This is the kind of stuff you will see. It looks like InfiniBand, it feels like InfiniBand, it smells like InfiniBand, not actually InfiniBand. So some things are not, 100%. Should you, individual person, should you do this? Maybe. You really need to, again, want it. We had a lot of existing skill set that made us pretty confident that we were going to be able to make something happen here, like that it wasn't just going to not work in a raw way. As I said before, we already did a huge FCOE implementation on critical enterprise systems, so we had pretty strong confidence in DCP and Converged Ethernet. I have some relatively deep networking knowledge because that Converged Ethernet deployment before was my deployment. I was, sent to a Cisco training and everything, so that's makes me an expert. Obviously, our campus networking team also is just kind of, they're very good. They're very interested in helping out. They like playing with weird things also, and most of the campuses pretty much, cookie cutter stuff. So being able to bring a crazy bizarro thing like RoCE into our HPC environment, some of them are very interested in that. So we've had great support from them. Todd, who I believe is on the call, is my supervisor, been very helpful with MPI debugging, tracking down what is going on with these user codes. You're going to need somebody to do that because, again, some of them just kind of act funny and you just have to figure out why. WWF, quality vendor wrestling. Wow, did we have to fight Broadcom? I mean, fight them to get how to do some things out. I think the situation would be better for you today. Better documentation already exists. They published things that were not published at the time. But at that time, we went to Penguin and said, some stuff isn't working. And Penguin said, here's Broadcom. And then that was it. We were just on the line with a Broadcom engineer, not one, I shouldn't say, many Broadcom engineers. And we're just shipping them a thing. And they're saying, well, that's not, can you isolate that and plug these things into something and do another test? And so we would go futz the hardware and try to run another test. And we would find a test that we thought demonstrated the issue, and they would say, oh no, you're doing this thing sideways, you need to change the setting. Like, well, then that's not the issue anymore. You just changed all of our parameters. What about this? Does this demonstrate it for you? It was a process. So you should be prepared for that process. And then obviously, from what I've already described, the pure uncut stubbornness to keep bashing your head into this wall until magic happens. This was not fast. Deployment time, additional deployment time. So in addition to what it takes to just bring up a normal computer and make it work, Todd and I talked about this. It was a year ago. So this is our belief now, looking back with the benefit of hindsight. This probably added 6 to 8 weeks of additional time to our deployment, just figuring out how to get a lot of the stuff that I was just like flipped through in slides. We had to work out one letter at a time, right? It just took a while. So if you have critical timelines and you don't feel like your upstream vendor is going to be able to come in and, wave a magic wand to make these things work, you should plan on it. Cumulus was new to us, so we were learning that also. Again, turned out that it was wonderful. If you're a Linux admin, Cumulus feels very comfortable because it is Linux. It just feels like Linux in there. Sometimes we would get things back from Broadcom that they would say, we'll just change this and then this thing will happen, and we would change it, and that wasn't what happened at all. But you'd kind of hear the echoes of, oh, what they're trying to do is X, and then you would figure that out. We got a pre-publication version of their how to set up RoCE with your Broadcom Fabric document. It was mostly correct, but sometimes you'd get to a section like, well, that doesn't exist. Where would you? Oh, I see. Circle a thing, send them a note. Yes, but you need to do this thing. And then we had some users that just volunteered to continue running their codes for us to test, which is very nice. It's always nice when you can find users that are willing to give you a hand debugging something like this. So just a fair amount of time involved in that part. Ongoing time commitment, even after you make it work. Again, like we're saying, like I have been saying, it still isn't InfiniBand. It's like InfiniBand, but it's not InfiniBand. So you're going to have some tickets. In our first year, as our users were kind of transitioning from our old system to our new system, I shouldn't say transitioning, our old system is still up, but as they were moving their workloads into this new system, we probably had 5 or 10 tickets that turned out to be RoCE related that Todd did a lot of debugging on. We still get some every once in a while that are just things that are related to the fact that RoCE has different device names or RoCE uses a different something. They're much less frequent now, but again, we still have some ongoing issues that we've been trying to debug for a while that we're still trying to debug. The fact that our pre-existing machine didn't get turned off means that those users are still able to run their codes there. So we're not, under a hideous amount of time pressure in terms of, if we don't solve that problem stat, we won't be able to run work. We have local policies like this, and I just mentioned them because I don't know how your computer is set up or what it's set up to do. We only let our PIs run 2,000 cores at a time, 8 terabytes of memory at a time, 500 total jobs at a time. What that fundamentally means is that for our machine, for this new machine, Puma, which is now up to 30,000 cores almost, they don't get to run a 30,000 core job. They're not running a 300 node mega job. That's not a thing that we allow our users to do because that's not the workload we're trying to solve for. So if that is a workload you're trying to solve for, some of the limitations of RoCE may be much more relevant to you than they are to us. Things like latency build up with more nodes involved in those kinds of workloads. And just to demonstrate that, so this is our old system, Ocelote, versus our new system, Puma. You can see that our core count went up dramatically from old system to new system. We had 28 cores in an Ocelote node. We have 96 cores in a Puma node. So for jobs on Ocelote, this is from 2020 when it was still our primary machine, you can see already the bulk of our jobs ran on one node with a little bit of traffic above one node. There are some jobs out there much higher than this, but this was our bulk. This is Puma for last year. More jobs on one node, some jobs on 2 nodes. So we're seeing a little bit more scaling beyond even what we were seeing on Ocelote, but fundamentally, and I should be clear, Ocelote is still in production. So there's still a lot of jobs running there even in 2021. But mostly I put this here to demonstrate that for our user base at a 96 core node, so many of our jobs fit on one node that even the impact of this not working as well as it could work is pretty mitigated. The bulk of our workload does not depend on this to work. We were able to reallocate a lot of cost by not having InfiniBand because we were doing Ethernet for the storage fabric either way. We wanted to have that fabric regardless. There was already going to be a 25 gig fabric going to these nodes. So on top of that, all the things that we bought, maybe it could have been different. It probably would have had less switches, but on top of that, just adding on all the InfiniBand switches, all of the cabling that you would have needed to set up all the spine leaves, the HCAs, for, I guess it would have been EDR at the time. May have still been FDR. I'm not positive. Roughly, right? Roughly at the cost we were paying at that time, we got about 25%, or we would have, I guess the other way to say this, lost about 25% of our initial core count to put InfiniBand in. And obviously that impacts every buy you have down the road also. You're buying those HCAs every time because, they need to be in the fabric. You're buying more switches down the road. Maybe maybe you run out of spine ports and you get to rebuild your entire spine. All those things just kind of add up over time. Again, if you need the InfiniBand, then the money is worth it. But if you can make some of the trade-offs like we could, then you don't really need to. Would we do this again? Yes. Todd and I talked about it again as I was setting up for this presentation. Like, we'd do this again, right? I think we'd do this again. It'd be better now for sure. I mean, a lot of things have changed in terms of Broadcom's documentation. The drivers are more mature. Things we would do differently. We had bids for Mellanox Ethernet hardware. There were some reasons, not just expense. There were other reasons we decided not to go with it. But in figuring out how to make RoCE work on Broadcom, as you're just Googling around for information, 20-30% of everything you find will either be in a Mellanox knowledge base document or somebody commenting on a Mellanox knowledge base document. They are very good at RoCE, and they seem to support it very well, which I think may have been a benefit to us, because the Broadcom engineers we ended up with, it's not that they weren't interested in helping us make it work, but they did not appear to have a deep customer base of people who were making it work. So it felt very much like we were getting information directly from the laboratory, if you will, which is fine. We kind of understood what we were signing up for, but Mellanox's story in terms of all of their docs and all of their things just felt better. As you're reading through it, in the end, you think, boy, that cost may have been worth it. Cumulus, which I've already lamented multiple times, you can still run Cumulus on a Mellanox switch, and I like Cumulus a lot. We did a full Ansible implementation for config managing our switching. We set up, ONIE and ZTP configuration stuff. Like, we did some strong baking automation and config management for Cumulus, and I'm very sad to lose it. So if we were buying another one, I would have to put a little bit of weight on Mellanox, just because I can keep my Cumulus, configs and keep some of that workflow in place. Fault tolerance. So I mentioned earlier that their congestion control script has the ability to configure for a fault tolerant design. We have 2 ports per node. We're definitely in a situation where if we lost either of those ports, the node is functionally disabled in one way or another, and there's no bandwidth reason that we can see currently that makes that a necessity. In terms of one node doing all of its storage traffic, if it had to have prioritized MPI traffic also on that same NIC, it would probably still be fine for us. So LECP is an interesting idea in terms of taking the 2 NIC ports and bonding them like you would for a traditional kind of enterprise server deployment, and just getting kind of the benefits of those things. Bonus bandwidth for your storage in the case when you're not using MPI, which could be valuable to some of our users, but fault tolerance in case you lose a switch or you lose a cable or something gets unplugged. I have tried and am currently in the process of trying to make this work. I have not yet succeeded in making this work. The script is, well, I mean, I'm not going to call it illegible, but it's a little bit difficult to decipher in terms of what it wants me to do so that it can set up the RDMA devices the way I want them set up. So anyway, I don't have any great insights on how to do LECP, but I would think about trying to figure that out if I was going to do this again. And that is fundamentally the end. This is a lovely shot of Tucson, and that arrow is literally where I'm sitting right now. I'm right under that arrow. So here we are at the end.
So there are a few questions already thrown out in the chat. I think Bergman had the first one. Actually, he's got a pair of them there together.
Okay, let me see. For performance observations, how do the same applications access to storage? Access to storage, performance function. So I should be clear, we're not doing like NFS over RDMA or any of that cool stuff. This RDMA implementation was just for supporting verbs and MPI workflows. We asked a little bit because we were kind of curious about that also. Microsoft is implementing a lot of RDMA stuff for storage now in SMB, which sounds very cool. Apparently improves their throughput quite a bit. Just not really a thing we found anybody that was willing to do. So just to be clear, that's all we were using it for. Same applications. In terms of applications that were doing the kind of MPI our users do, again, from our statistics on our previous cluster, we didn't have heavy bandwidth users, and we didn't have anybody that was beating up even message sending so much that latency was a big deal. So for our users that haven't experienced any other problems, any things that are just sort of endemic to RDMA or RoCE not being InfiniBand, essentially the same. To be clear, also, again, as that slide demonstrated, our core count per node went up so much that several users who were doing jobs that required MPI before don't have to use MPI anymore. They can just run the whole job on one node now. So anything that was 3 nodes or less on our old cluster is 1 node now on our new cluster. And that just sort of wipes out a bunch of the sort of low-hanging MPI jobs, which is, well, I needed 36 cores. Like, yeah, good news. We can run that on 1 socket now. So just, run it locally. You can still use, even if you still want to use your MPI, signaling or however your thing is compiled, you don't have to cross the InfiniBand fabric at all to solve those problems. So why not use Mellanox 25 gig NICs with Mellanox OFED stack? Did I skip one? No. That was bid. So we had two reasons for that. Very specifically, the platform that they bid at the time, I'm going to not say a model number because I'm going to get the model number wrong, had a very strange limitation in terms of breakouts to 25 gig, which is that for a 36 port switch, only 18 of them could be breakout ports. And I sort of guess I might understand how that happens in a full non-blocking kind of fabric. But for us, we were going for a blocking fabric and we needed more breakout ports than that. The only way to resolve that problem at the time was to use the half width version of that switch so that all the ports were breakoutable. But of course, the half width version doesn't cost half as much. It costs, 20% less. And so all the costs just sort of started spiraling. We looked at using native 25 gig versions of the switching. You just start running into density issues. So even a 32 port, which is what we ended up on, 100 gig switch will break out to 128 25 gig ports all told, 96 for our purposes, right? Well, that's 96 nodes that you can plug into that one switch. With a 25 gig 1RU switch, you often end up with 48 by 25. That's just not as much density. So you need even more switches, which means you lose even more rack units, which means you lose more compute rack and density goes down. So those things kind of piled up. There was also cost. Even if that Mellanox switch could have broken out all the ports the way I wanted it to break them out, it still would have been much more expensive than our Broadcom solution. Again, there was a soft value that I have understood more now as to what I was paying for there. Specifically for RoCE, I think their story is pretty good in terms of implementation and documentation and good support. Even in Cumulus at that time, which was not owned by NVIDIA, to set up the congestion control parameters on the switch, the traffic.conf stuff that I was talking about, there's a helper script for Mellanox ASICs only that they provide with Cumulus before they were even owned by NVIDIA. So there was a simple command, set up RoCE on your Mellanox switch, type 7 characters, press return, problem solved. We had to sort of figure out what that was doing and then figure out what parameters Broadcom preferred and sort of munge those things together. So there were values there, but at the time we just decided to optimize towards cost because we felt like we could get it done, and we did, right? But would I try that again? What storage system did we go with? I see the guys answered that. Yeah, we bought a Cumulo P series NFS based storage system. So we've got 17 nodes of the P184. It is unbelievably fast. Easily, I think my whole team would agree, best storage system we've ever purchased, ever, hands down. So that's a discussion for a different time, but could not say enough nice things about Cumulo. It is a wonderful experience. It is not cheap to get their all NVMe storage. So we had some performance problems with spinning disk storage on our previous systems. And we went to our faculty and said, can we please overspend this time? We don't know how much of a bottleneck we have. If we incrementally go up, we may just hit a new wall. If you will support us spending a little bit more than we typically do on storage, a little bit, we can guarantee that storage will no longer be your bottleneck. That's a promise. If you buy this, that we can no longer get there. Anything you would do to make it even faster than this is so expensive, it's irrelevant. And they absolutely agreed to let us do that. And we haven't talked to a faculty person, talked to a campus constituent about storage problems since. Bar none, no more problems. Problems with their quota, problems with their file permissions, problems with the normal stuff, absolutely no performance issues. No user has been able to sort of sneak in and put in the dangerous job that produces 1.7 trillion IOPS that they don't realize is producing 1.7 trillion IOPS and drags your storage system into the earth, and then nobody can log in. It doesn't exist anymore. It just doesn't happen. So anyway, it was great. And that system is all 100 gig native. We put it behind a pair of 100 gig switches, and we have, I'm going to say 800, I believe it's 800 gigabits of switch to core bandwidth for Cumulo. and that is shared with Puma, which has its own 100 gig uplinks, with our previous system Ocelote, which is uplinked at 40 gig, and with another system which we built our own InfiniBand to Ethernet routers out of old servers because we needed to solve this problem to get them to Cumulo, and all they had was InfiniBand. So all of those things are all talking to Cumulo at the same time. That's 3 systems, and still just absolutely no concerns there. So what other storage alternatives did we consider? We had a lot of bids. We had GPFS, which is what we were using before. We had 2 different GPFS bids, DDN and boy, I'm going to blank out. Rick or Todd or Chris may have better memories.
IBM bid a whatever their thing is, appliance.
The appliance-based GPFS. Yes. Panasys, I believe. What else? This was a little while ago, so apologies. But DSS, Todd, thank you. That's what IBM bid. So kind of typical stuff. We had DDN before, I guess I could say. We had the DDN 12K-X was our existing. We had a 12K-E and a 10K before that. A lot of good history at DDN. It was one of those situations where that type of system, and we weren't building, an all-in NVMe DDN here. This was mostly spinning hard drives. That sort of system was perfect for us until it wasn't. It just, the transition from, oh, this is fine to, oh, this isn't fine was like falling off a cliff. And then there was no more fine. It was just absolutely over. We just couldn't make it work anymore. So, so what we ended up taking all of those bids and looking through them, trying to figure out how we were going to score it, and essentially deciding that we could do on-state contract what we needed to do. So we leveraged a contract vehicle to buy Cumulo because it was available to us to buy through, I'm going to forget which contract vehicle, but one of our sort of contract vehicles supported us to be able to just buy the thing that we knew we wanted. And that's what we took to the faculty was, we have all these bids. We think some of these things would work, but we think this is the right solution, and we don't have to do RFPs to get this solution because it's on contract. So sometimes, take the easy road. When you got started out, Broadcom is advanced. Yeah, so kind of the stuff I'm talking about around documentation. I should be clear, we don't have much contact with Broadcom anymore. They helped us get through some of our sticky issues in the middle, but we're not really pushing stuff back. We delivered a high-level summary document to our integrator, which is Penguin, for the system. Like, they asked us, hey, you guys made RoCE work, or at least the work it's going to work. We have other customers that have some interest. Could you kind of summarize your experience? So we pushed a little bit of that stuff back up. But in terms of, does it work any better today than the first day we got it to work? I wouldn't say there's a dramatic improvement there. Fundamentally, it was figuring out how to put all the puzzle pieces together. It wasn't really a situation where like, oh, well, the driver needs to improve and performance will get better. That wasn't the sort of stuff we were waiting on. It was, I don't even see an RDMA device. How do I get it to do the thing I needed to do? And once we got it working, it has essentially continued to work. We were pushing firmware updates for a little while just because we kind of expected we'd need to push firmware updates a little bit more aggressively, but we've since standardized on a revision from, I'm going to say late last year. Just kind of, this one works, we know it works, it's working with the drivers. So until we find a reason to upgrade, we're just going to kind of hang out. I don't mind pushing firmware updates if it's one of those things where you're kind of on an edge and you sort of need to keep tracking to keep features going up. But the current firmware we have does all the things we need to do. So we're sort of stabilizing there. So fundamentally, I think like we were saying, like I said in the slide, it would be easier to do now, especially for us because we've already done it. If I had a document like this or the artifacts that I'm providing here, that would have saved us a lot of time because some of that stuff was just hammering it out, one nail at a time. But I would still estimate probably 4 weeks or so of futzing, even if I got another Broadcom RoCE. Again, if it was, a different NAS, most likely moving to CentOS 8, like just the normal ebb and flow of some of the software stacks, we'd have to resolve some of these problems. We just have the benefit of knowing how it used to work to help us know how it would work in the future. So So I think it would be easier to do. I think you'll probably find the story with the vendor is maybe a little better now also. I don't know that we were Penguin's very first RoCE implementation, because I mean, they didn't say that to us or anything, but I didn't get the feeling they had a bunch. It wasn't like, hey guys, we're having trouble with RoCE, and they're like, hang on, let me go get Steve, the RoCE expert. Like, that's not the experience we had with them. If you were with an even larger vendor, maybe a Dell would have more folks, or an IBM, or I should say Lenovo. It's possible that they have, internal work teams that have really ground this out in their own laboratories. But our experience was very much like, well, Broadcom says it'll work, so we sold it to you, and now they will help you make it work. And I mean, that's what happened. But the document that we pre-release received is released now, and it was essentially a document that summarized a lot of the things we had to learn by trial and error. It just came very late in our process, so all we needed was like step 5 and step 14, because those are the ones we were missing. It's much clearer now, like sort of their process for thinking about how to get through the things, so that would be a lot more helpful. But it's still, again, I think if you were setting it up on all Mellanox, I wouldn't put as much of a handicap on it. They feel like, and I didn't talk to them about this, I'm not saying from experience Mellanox has a better story. Just from their documentation, I feel like they would be willing and able to provide you with a lot higher level of how to make the thing go than we got from Broadcom. So, but with Broadcom in particular, since they've certainly gone through it with us, and there must be more customers than us, right? There must be probably be a better story today, but it's one of those things. You should, again, be ready to put some elbow grease onto this sort of thing. So.
All right, Adam. Maybe time for one more question from Sai. Does CentOS 8 end of life affect your upgrade path from CentOS 7?
Tying it into next week's topic, we have settled on RoCE 8. We looked at some alternatives, and we like RoCE. Looks good. Looks just like CentOS was supposed to look, except it's not called CentOS anymore. So we've been moving some of our utility machines onto RoCE 8 already. We use some migration tools to migrate some pre-existing CentOS 8 machines to RoCE 8, which all worked pretty flawlessly. The cluster I'm trying to set up right now is all RoCE 8. So that's essentially where we're going in terms of CentOS 8. I said CentOS 8 because my brain is still locked into the old world. But yeah, when the guy that made CentOS starts another distro to make CentOS again, it feels pretty good. Like, you feel pretty confident that you can go over there. It's probably going to be all right. And so far, our experiences, it's exactly what you expect it to be. So.
All right. Thank you, Adam.
No
thank you for the great talk. Next month, we will be convening again, and the topic will be post-CentOS 8 era community discussion. So thank you all for attending, and we'll see you next month.